All right. Hi everyone. Welcome to an extra offline video where we will deep dive into Recoil. We'll go from the basics again and then understand some slightly more advanced concepts. I would urge you to clone this repository locally. It will be super helpful today, specifically for the advanced things that we're covering, and the basics should be straightforward. I'll still try to cover them via examples as well as through some basic code that we can write locally. All right, cool. So what are we discussing today? We're discussing atoms, selectors, asynchronous data queries, use recoil state, use recoil value, use set recoil state. All of this we've already covered in 7.2 other than asynchronous data queries. So this will be something new. In the advanced section, none of this we have covered until now. We will cover atom family, selector family, use recoil state loadable and use recoil value loadable. These two extra ways for you to get state. All right, let's get right into it. Let's start small here and let's re-understand what is an atom. Let's say you're supposed to create this top bar for LinkedIn. What are the dynamic parts of this specific component? It is this notification count. If there is a notification count here, that if there is a notification count here, that as well as this notification count, everything else remains constant. These four things change. The numbers here change as you scroll your LinkedIn. If you open your LinkedIn and open it, keep it open for 20 minutes, you will see this go up from 12 to 14. How would you store these in case of React? You would store them in state variables. You would use the use state hook that we have talked about many times until now. But if you want to do state management, if you want to use an external library like Recoil, you will store them in atoms. An atom is the most smallest unit of state that you can store, similar to use state. Use state is one way to store these variables. An atom is another way to store these variables. If you're using Recoil, you would use an atom. I have defined 4 atoms here: network count, jobs count, notification count, and messaging count, each representing what is the current set of notifications a person has. This person has 102 network notifications and hence 99 plus appears here. We can write that logic whenever there are more than 99, we just render 99 plus here. Similarly, this is 0 and we can write the logic if there are 0 notifications, don't show a bubble here, 0, and this is 12. These should be flipped, but you get the idea. 12 should be here, 0 should be here, and this represents the notification count. Let me, cannot fix that. And these are the 4 atoms that I will create for my React application. Let's code that first before we proceed so that we're in the groove and actually coding some recoil logic. So with me, open, if you want to, a terminal, create a fresh project, create wheat. This is a new laptop. Wheat. What is the command that you have to run to start a React project locally? It is npm create wheat @latest. I'm going to name this specific folder, call it 7.4 easy bits. Select React as the framework, select JavaScript as the library, and open this up in Visual Studio Code. Once I have this here, I'm going to run npm install to install all the dependencies. And along with all the default dependencies, I will also install Recoil here. So npm install Recoil after this finishes. There we go. I installed Recoil as well. Now I have to write the logic to create 4 atoms and also create the LinkedIn top bar that you saw on the slides. We'll not make it as pretty. We'll just try to create 1, 2, 3, 4, 5, 6 buttons and add some dynamic part in this, and this button. All right. Let's go to app.jsx and make it completely empty. As always, make index.css empty, make app.css empty. Now that I am in app.jsx, I'm going to define 4 buttons. Button, what was the first button? Home. Second one is my network. And then inside brackets, I will write my network notification count. Third one is jobs. Fourth one is messaging. And fifth one is notifications. And last one is this guy right here. It says me. All the ones in the middle, the 4 important ones in the middle, will have some number that I need to write inside, which represents the current amount of notifications you have. If I restart this by running npm run dev, you will see I have 1, 2, 3, 4, 5, 6 buttons. First and last one we can ignore. These need to have real values inside. How do we do that? How would you do this if you did not have access to the Recoil library? You would define 4 state variables. You could be like notification count, set notification count equal to state 0, and then define 4 such variables, 1 for each one of these. You would put some random values here and you would say, Harkirat, I've done things the right way. I have 4 state variables. I have these values which render the state variables, and we can always write the logic to connect to your LinkedIn backend and update these state variables as time goes by. But we don't want this. We don't want to do this via the use state hook. We want to use the Recoil library. For that, as I said, you have to define 4 atoms. Think of atoms similar to being use state, only they're the recoil way to do state, and they're slightly more optimal compared to this use state hook. You can define them in this file itself, or you can create a separate file. I'm going to create a separate file called atoms.js, and here going to export 4 atoms. Export const. What is the first thing called? Let's call it network. Network atom equal to atom, which automatically got imported from Recoil. If it did not for you, feel free to import it here. What does this take as inputs? It takes 2 things. One, a key to uniquely identify this atom. It's going to be network atom for me, and a default value, which in our case is going to be, let's say 12 for, what is it here? It's 99 plus. So let's make it 104 here for the first one. And similarly, I can define 4 such atoms. Jobs atom, which is going to be 0. Notifications and messaging. So notifications atom, which is going to be 0. And then lastly, messaging atom. This was actually 12, and this will be 0. So these 4 atoms are these 4 green things right here: 102, 0, 0, and 12. 102, 0, 0, and 12. Okay. Now I need to take these into consideration, basically get their values here and actually render them here. For this, there are multiple ways to get values. The one that we are going to use, the hook that we are going to use, that Recoil provides you. Recoil provides you a lot of hooks. Use Recoil state, use Recoil value, use Recoil, use set Recoil state. We are going to use Recoil value. Let's see what this hook gives you. I'm going to say const network notification count equal to use Recoil value of the network atom. Where am I getting network atom from? From this atoms.js file, this export that I did. And I said I need the value of this here. Use Recoil value. Hook gives you the current value inside, basically the actual number. I get this and I can simply be like, okay, bhai, I'm going to render this here. Ideally, what should you do? You should render, okay, bhai, if this is greater than 100, then render, or greater than equal to 100, then render 99 plus, else render this notification count. If this feels like extremely hard syntax, you can do something like this. Const final value equal to this. Okay, bhai, if this is greater than equal to 100, then render this, else render this. This is the ternary operator in JavaScript. If this feels weird as well, this will work. If this feels weird as well, you can do an if else here. Okay, this value is equal to this, and then if final value is greater than 100, then make it 99 plus. Whatever syntax feels easier to you. What is the best syntax? The first syntax that I wrote, where we did everything in line, which is this syntax right here. I was able to create an atom. I was able to get the value of the atom in my component, and I was able to render it right here conditionally based on what the value is. This is a complete replacement of use state. What was the other way to do it? Use state, define it, the default value here, and then, do something like this, set whatever, network count. All right. So this was the original way to do it. We are not doing it using use state. We are doing it using recoil. Great, Harkirat. Let's see if this works. It does not work. Why did it not work? Because any time you are using recoil, specifically any recoil hook, if you want to use any atom, if you want to access, it needs to be wrapped inside the recoil root. This component needs to wrap every component that uses a recoil hook. And since we've done that inside app, we need to wrap this app somehow inside the recoil root. What I would do at this point would be take all of this and move it to another component, function main app, and do all of this logic here. In my top level app, I would be like recoil root, and inside I would do a main app. So what have I done? I've said app will first render the recoil root, and inside I'm passing my main app. This is a new component that I defined, which does all of my logic. So this is how I can make sure that any place I'm using a recoil hook, which is this place right here, wherever this is being used, is wrapped inside a recoil root. That is how you can make sure that this actually works. Recoil will only work, or more specifically, you can only use a recoil hook in a component that is wrapped inside recoil root, else it will fail. All right. Save, refresh, and we see everything. It says my network 0. It should ideally say 99 plus. The default value here is 102. And what is our logic? If it is greater than equal to 100, then this, else this. Let's see what the error is here. Use recoil value, network atom, default value. I think it is default. I hope you can already figure out what the issue is. This is how I would debug the issue. I would log the atom, and it says 0 here, even though network atom has been initialized with a default value of 102. Let's see, let's try that one more time. Ignore the errors here. These come when you're using, so whenever you're in recoil, using recoil in dev mode, which basically means you're in strict mode, you will see this error, which you can safely ignore, or you're seeing it otherwise as well. This happens when the application hot reloads, so don't worry about this error right here. Oh, no. Do worry about this error. Finally, I see the issue. I have repeated keys throughout. This is why you should never repeat keys. Okay, bhai, jobs atom ka key should be jobs atom, notifications ka should be this, and this ka should be this. This was the reason why I was getting the 0 value, because it was basically overriding the original network atom. So make sure the key that you're defining here is basically unique for every atom. This was the issue that I had in my code currently. Now, if I refresh, it says my network 99 plus. All the errors go away as well. All right. So the error was pointing us in the right direction. And this is how I would build the first atom that I'm using throughout my application. What have I done to recap? I'm getting the value for the network atom and then rendering it here conditionally. If it is less than 100, do something, greater than 100, then render 99 plus. And that is what is getting rendered here. We have sort of started to create this top bar right here. It does not look as pretty. We have to add a bunch of styles. Yes, but assuming we can take care of that, the state management is being done right. Now let's quickly finish the rest of the atoms. So what is the second atom? ideally I should write this logic for all 4 of them, because I want all 4 of them to conditionally render 99 plus or this specific value, but I'm not writing it so that it doesn't get too verbose. So this is what the code looks like finally. And I need to wrap these inside brackets. If these brackets feel confusing, the first outer bracket is just for aestheticness. You can remove it. The actual thing that you see is curly braces and the JavaScript variable which stores the final value. This is what is important. If I refresh, it says 99 plus 0, 12, 0. We have been able to recreate this top bar right here, 99 plus 0, 0, and then 12, 99 plus 0, 12, and 0. You can flip out the state variables to reach the exact place. Messaging is 0 and notifications is 12. So let me do that. Messaging is 0, notifications is 12. Let me render it the right place. Messaging should render the messaging, this thing, and notifications should render this thing. And then we have the final top bar, which looks very similar to this top bar that you see on the right. That is all you need to create a top bar like this in a dynamic fashion, where you have state variables that you can update, and those updates would flow here. For example, I can write, let's say the last button, if you click on it, I can be like, bhai, when the last button is clicked, a new message comes in. So I can be like, set message atom count to C+1, where again, you can use this syntax. We've talked about it many times. You can use this syntax to get the current value and then give out the final value given this default value. If this feels confusing, you can do this +1. यहाँ पे, rather than using use recoil value, I no longer need just the value of this atom. I need the value and the function that lets me update the value. And for that reason, I'm going to use the use recoil state hook. I repeat, I'm going to use the use recoil state hook, which is different from the use recoil value hook. This one gives you 2 things similar to use state. Use state also gave us 2 things. 1, the actual value. 2, a way to update the value. Similarly, if you ever want to update a variable, you need to use the use recoil state hook and not the use recoil value hook. That's the difference between these 2. And now, as you can see, when you click on the last button, I'm increasing the value of this atom by 1. So what will that do? That will basically increase. If I click on it, you will see this messaging notification number goes up. So this is how you can create a dynamic app. Of course, in the real world, this will not get updated by me. There will be some backend call happening somewhere that will, keep updating the notification count based on what the number of notifications are on the backend, just to simulate and show, and basically show the usage of use recoil state. I have done this. One hook that we haven't discussed is the use set recoil state hook, which is basically, okay, if you only need this thing, if you only need to update something and not actually want the value of it, you use the use set recoil state variable, and that will return you basically just the function and not the initial value. Harkirat, where do we need this? Great question. What if I said, okay, you need to put this button in a different component? I basically said you need to create a new component called button updater, and here you need to put the final button. Now this button updater only needs set messaging count atom. It does not need the actual value. If I'm using this syntax, this specific syntax, in which you can pass a function inside, this does not need this value anymore. It only needs the setter function. And so I can yahan pe be like, okay, bhai, you will only get use set recoil state. So you can update the state. You don't really need access to this value, messaging, because this guy needs to render it. This main app needs to render it. This main app no longer needs to update it. this button updater needs to update it, but no longer needs to render it. So this guy will use set recoil state. This guy will use recoil value. If you need both of them, then you use recoil state. So that's the difference between these three hooks: use recoil state, use recoil value, and use set recoil state. Hopefully that is clear. Atoms we understand, use recoil state we understand, and these three hooks we understand. Let's go back to the slides. Let me also revert this, because we're going to do something interesting afterwards. So let me revert this code so that we basically have this. The last button was just a me button. Clicking on it does nothing. We have no more updates. We can write the logic to update when we have a real backend. We don't have a real backend right now. So this is what our application looks like. All the values hard coded here, all the values being fetched here and then being rendered in these 4 buttons right here. All right, cool. Let's proceed. Done with atoms. Next up, we would do selectors. So this, hopefully we understand that every dynamic app, the dynamic part of your app can be put inside an atom if you're using recoil. But what are selectors then? Let's say you want to show all the notification counts above your avatar. I repeat, if 12 is the number here and let's say 102 is the number here, then you want to render 114 here. Let's say this is a use case that comes that the person needs to see the sum of all of these values here on top of their avatar. How would you do it? Would you introduce another atom, or can you do something else? Do you need to introduce another atom? In the end, this value is just the sum of 1, 2, 3 and 4, right? If you know that this is just the sum of these 4 values, do you need to introduce a new atom, or can you do something else? Let's start with the ugly approach. Before that, hopefully you understand the visualization. Okay, this specific value depends completely on these 4. This value you will not get from the backend independently. You will only get these 4 backends values from the backend whenever you create your LinkedIn backend. This is derived from all 4 of these values. So let's see how can you get this final number given these first 4 values. Harkirat, I know this. I can be like final or total notification count equal to the sum of the first 4. So this thing plus this thing plus this thing plus this thing. This would solve our problem. I would just render this thing on the final me button. And then I know that I've been able to create something that the slides expect. The sum of these notifications I was able to put here. Let's see if this works. As you can see, it added all the strings together. Basically in JavaScript, 1 plus 1 is actually 11 if these are strings. So we need to convert them into numbers first. There are multiple ways to do it. Which one of these is a string? Okay, let me just make this a number and then this problem will go away. This was a string, which is why it was concatenating them rather than adding them. Now if I refresh, it says me 114. Great. You were able to solve the problem. You created a variable here. What is the problem in this approach? We have discussed this last week, not the last week. The problem is you are not memoizing this value. You have not used the use memo hook, which would make sure that only if these 4 values change, do you actually recalculate the sum. If none of these values changes in a re-render, which could happen if there is a state variable here, if there is something else that's triggering the re-render of main app, you don't want to recalculate this. So you should ideally wrap this inside a use memo. That is one thing you can do, and at the very least you should do. But there is another thing you can do. Rather than, let me show the use memo thing first. I can be like, okay, bhai, this is the final value. And it depends on these 4 state variables. This is one thing you can totally do. And this is something you should definitely do if you're thinking of creating this. It still works the same. It is slightly more optimal because this logic has now been guarded and only runs if one of these values changes. This is great, but there is something better. Recoil gives you access to something called selectors, which can pretty much do something very similar. Let's look at the syntax first and then go from there. Let's create a new selector here, not an atom now. Exposed const total notification selector equal to a selector, which again takes two keys. Key, which is the key for this specific selector. You can have any random name, just make sure you're not repeating any of the names. And then finally, the value. Okay, bhai, how would you get this specific selector? How does this depend on other values? How can you get the final value given all the other state variables that this guy depends on? What is a selector? If you look at the slides, a selector is something that can be derived from other atoms or even other selectors. If you have a bunch of atoms and you know there is a value that directly can be derived from these, does not depend on any other external source, does not depend on your backend, then you can simply be like, okay, bhai, I am going to define this as a selector. And this is the syntax for it. The way to create a selector is you give it a key and you give it a value. The value is a function which gives you access to this get object. And here you describe, okay, bhai, how does this selector depend on other things? In your case, what do you have to do? You have to be like, okay, bhai, this depends on the value of the network atom. So you can be like this equal to get, give me the current value of this guy. Give me the current value of basically all four. And then finally, the way to reach the final value is this logic right here. What have I done here? This defining this selector, or more specifically, the logic that I've written inside this function, if you look at it, it's very similar to this use memo right here. What does this use memo say? It says anytime these four change, this needs to be recalculated. And what does our selector say? Selector says anytime this changes or this changes or this changes or this changes. If you use get inside the selector, Recoil understands that theek hai bhai, this selector depends on this selector depends on this and this, similar to the slides right here. We have told Recoil that by this value depends on all four, and this is how you can find the final relation. Given these four inputs, how does the final selector look like? How can you find the final total number of notifications? And now you can use this directly here, similar to how you've used these four. The syntax remains the same. Const total notification count equal to use recoil value total notification selector. So the first four depend on atoms. This guy gets the value of a selector, and this selector internally depends on these four things. That is how you can create the thing that was expected from you in the slides, which was the final notification count using selectors. Can you create it without selectors? Yes, as you saw, I can just do this, but this is the better approach of doing it. I'll quickly / very soon share why, but let's see if this works. It does work. We have 114 here. Selectors must specify a callback option. Selectors get, the value here is get. It's my bad. The key to use here is get. And now if I refresh, I see 114 here. If I uncomment this, I still see 114. Both the approaches work. But why is this approach better? This approach is better because if in the future you have another thing that depends on, let's say, this guy and this guy, you can create that new selector. I repeat, if there is, let's say in the future, another variable called total notifications plus the total messages you haven't replied to, hypothetically, let's say you need to show another icon here which shows you this number as well as something else. Now you can say that new selector depends on this as well as some other value. So you can keep creating these dependencies as long as you are defining the selector. If you don't define the selector and go down the other route of using a use memo, what will happen is you can't use this variable outside in other selectors that you create in the future. That is why this is a slightly better approach than doing this is a slightly better approach than doing this. And if you are using recoil, if you know something depends clearly on other atoms, create a selector rather than going down the use memo route. This will still work, but this is a better approach. All right. Try to code this yourself. Let me also publish this to GitHub. So if you want, you can look at this code as well. But that's a high level of how I would. CP 7.4 easy bits. How I would understand selectors and atoms from the basics, and this is all that we excuse me, all that we need to understand before we get into some slightly advanced concepts. All right, let me quickly push this up and then we can go from there. I'll push it after the slides. All right, let's move on to the next section where we will understand slightly more advanced concepts. We've built the app bar. Let me go back to the slides here. So we understand selectors hopefully now. We understand both atoms and selector by creating this app bar component with some hard coded values. Thing to keep in mind, we have been using hard-coded values. We have not yet hit a backend to get the values. That should be your next question at this point, Harkirat. This is a very simple thing to do, your hard-coding values. How do we actually hit a backend to get these values and populate them here? Can you show that? How can I put values from a Axios request or a fetch request into these atoms? Let's discuss that next. We need to next get into asynchronous data queries. Everything in green we have covered once. Asynchronous data queries is what we're covering next. All right, we're at this stage right now. We've done atoms, selectors, and 3 hooks. Next up, we're going to learn something new, something we did not discuss last week. It's called asynchronous data queries. Basically, what we want to understand is, what if this was a real LinkedIn application? By this, I mean, if you actually had to hit a backend, get back the data from there and show it up here, how would you do this in a real world scenario? Let's say this is the backend server that gives you the data. I've already deployed some code here and you will probably see this code up and running for a few days. If you look at this, this returns you an object which has 4 keys: network, job, messaging, and notifications. And these are the current notification counts. Assume that you have a real LinkedIn application. This is the backend route for it. You have to hit it, get back the data, and then show that data on your LinkedIn app bar propagated via Recoil. So that is why it says asynchronous data queries, because this data you won't have access to immediately, just like we did in the last slide. Now you have to actually hit a backend, get back the data, and put it in your Recoil state. How would you do this? I've written some starter code already, which is available here as well. So if you go to, why am I playing sad songs here? If you go to github.com/100xdevscohort/7.4, you will see 7.4 async queries. Download this, open this up locally, and that is the starter code for this section of the video. If you look at the code, I have modified it slightly to make things a little bit simpler, easier, and consolidated. But at a high level, it does what you would assume an app like this does. How would have you built something similar if you knew Recoil wasn't in the picture? You would have had a global state variable here. You would have been like const notification counts set notification counts equal to use state empty object, and then you would have had an effect with an empty dependency array, which means this code should run on render or on mount of this specific component, and you would send a backend request, get back the data, and update it in the state, and then finally use this variable throughout your application. That is how you would have done it if this was not a Recoil application. But now that we're doing state management using Recoil, what can you do? You can be like, okay, number one, I'm going to consolidate all of these into a single atom. So if you go to atoms.js here, you will notice I've consolidated all of them into a single atom rather than having 4 different atoms. This is just for ease of looking at this atom and not having like 4 different places to track. You can totally go down the other route as well. But this will make things slightly easier. If you do go down the other route, you will have to change things a bit when you're reaching asynchronous data queries. I can explain what that is at the end as well. This will make your life slightly easier. So I've consolidated it into an atom. Atom now is an object or returns an object rather than a single number, and it has 4 keys. Let me default this to an empty object to begin with, and eventually values will be propagated here. I have the other selector as well that sums up all 4 of these keys whenever they get propagated here. So this is still the same as before. This is a single atom where I've consolidated everything. Feel free to pause and understand this code base. Now, in the use effect, what am I saying? I'm saying I'm going to still send the request out, and I'm going to, when I get back the data, update this network count atom, put the data here, and then we're good to go. Only difference of this from how we've done things until now is rather than using useState, I have defined an atom that is storing my complete state, which basically means all my notification counts. And this other thing is just dependent on this. Now that I have this, I finally render the 4 notifications: network count.networks, network count.jobs, messaging, and notifications. And then finally, a button at the end that shows you the sum of all the notifications, basically the same app we created a while back. Feel free to look at the whole thing top to bottom, pause it, clone it locally, try it out, and you should see the things work as expected. If I go here, you see something broke. I probably need to give default values here. Let me give it a default value of 0. This will all not be a problem soon when we actually solve it the right way. This is actually the wrong way to solve it. Let me give default values of 0. Now if I refresh, it works as expected. You see a flash for a second, as you can see. 0 for a second, and then eventually they get fixed. We will see how to fix this later as well. But we have a basic functioning application. How you would build it if you did not know the way to do it in Recoil. This is how you would do it. If you were like, acha, rather than storing it on state, I will just store it in Recoil and we're good to go. Is this the right way? No. But this is a dumb first principles approach of solving this problem. Rather than storing things in state, I'm going to store them in Recoil, and I have an app finally that is sending out a request to the backend, some server.100xdev.com/notifications, getting back a response, and then with the response actually rendering it on screen, this guy being the final accumulation of all the values here. This is not the right way to do asynchronous queries in Recoil. The reason for that is there are a few reasons. Number one, as you see, there was a flash. There's a flash of 0, and then eventually you see the values populated. The reason for that is you have an effect here. Firstly, the default value will get rendered. And then once the default value is rendered, the request goes out, response comes back. Then you render the actual thing, which is why there is a small flash. If I zoom in here, you will see 0 here for a second, and then the actual value is propagated. That is the first problem. The other problem is it's just a lot of ugly code. All of this should probably reside together, specifically this specific logic. This axios.get should somehow reside here. I shouldn't give it a default value of 0. I should be like, bhai, this atom is going to hit the backend, get back the data, and then that will be the default value of this notifications atom. You shouldn't default it to zeros and then eventually change things here. That is the other problem for this approach. So what do we want? We want rather than returning a synchronous object here, I want to actually hit the backend, get the data, and store that here. Basically move this use effect in here. How can we do that is the question. Can we do this? Can default be a function that does, an axios.get, and then, whatever data you get, you return? Can I do this? If I can convert this into an asynchronous function, which actually hits the backend, gets back the data and returns the data. This would be nice. This would be one way to get rid of this effect right here. All the network count computation or this specific computation resides in the atom itself. But this will not work. If I refresh this page, you will see an error. The error basically is this cannot be a function basically. The default value for an atom needs to be synchronous, or it can be a selector which can be asynchronous. This is where the concept of asynchronous data queries comes into the picture. Specifically, how do you solve for this specific use case inside Recoil? Let's go to Recoil docs and see what it says. If you go to guides here, the first thing after atoms and selectors is asynchronous data queries. Recoil provides a way to map state and derive state to React points. The important bit to read through here is this one right here. Selectors can be used as one way to incorporate asynchronous data into the Recoil data graph. What's really powerful is that the functions in the graph can also be asynchronous. This makes it easy to use asynchronous functions in synchronous React components and render functions. Recoil allows you to seamlessly mix synchronous and asynchronous functions in your data workflow, yada, yada, yada. Feel free to read through this. You will not understand it the first time. You will understand it as you spend more time doing this and then come back to it later on. Basically, if I would have given you this problem statement to begin with, is when you would have, hit your head left, right, and center and try to figure it out yourself. And then eventually this would have made sense. Since I'm giving you the solution up front, this might not make sense right now, but eventually might. What is the high level? High level is selectors can be used as one way to incorporate asynchronous data into the Recoil data flow. Please keep in mind that selectors represent idempotent functions for a given set of inputs. This is be cached, restarted, or even valid multiple times because, okay, sounds good. All right, let's look at the logic. This is sort of important to know what is idempotent and why are they saying selectors are idempotent. Why should you remember this? We will come to this if need be, but you will basically see problems when you have asynchronous selectors like we are doing right now. And you want to do, for example, if I change this problem statement and I tell you, okay, you have to constantly poll the backend, is when you will see this becomes important. But for now, I just asked you to do it once. So let's see how to do that. What's the logic that they've written? They basically say, if you are defining an atom that needs to have an asynchronous output, what can you do? Let's see. There you go. That looks right. This is how you would write your atom if you know its default value is going to come from an asynchronous function. I repeat, if you know the default value of an atom, which in our case is all these notification counts, if you know they're going to come asynchronously, this is how you would write your atom. You would give it the key and you would say default is a selector because you cannot have asynchronous default values. This cannot be an asynchronous function, but this can be a selector. So the default value is a selector in itself, which you can give it whatever key you want. You can call it network atom selector. And here the get function can be asynchronous. I repeat, here the get function can be, what was get usually in selectors? It was a function, right? So this function can actually be async. It does not depend on anything, so we don't have to worry about get. And here I can run all of this logic. This is the syntax, which is might seem a little ugly. Up until now, it looked like this. This was an object. Now this is not an async function. It is a selector, which you can give a random key to. Important thing is the get of the selector. Just like this selector has a get, this selector also has a get. This can be asynchronous, which is why we're able to hit the database or the backend, get back the data and return. This is how you would do asynchronous data queries and give an async value to a notifications atom. If I go back and refresh, it does not work because Axios is not imported. Let me import Axios at the top. Now if I refresh, seems to work as expected. You might have a few questions. specifically, this is an async function. How is this rendering? Why do you not see the flash, the 0 followed by some buttons, which you will get to soon enough when we answer or when we reach this section of use recoil state loadable. For now, if you have the question of Harkirat, if I'm refreshing, how are their values coming here initially? It takes a few seconds for the data to come back from the backend. So how are they immediately coming? Why is there not a flash here? And the answer is there is a flash. You don't see it because the flash is a white screen itself. It's no longer, zeros being present here. That's not the flash. The flash now is, initially the screen is completely white until the backend actually responds back with something, and then you see the values here. You can confirm that by adding an artificial delay here. Right now, this request is resolving very quickly, so you don't see it. I can add an artificial delay here. I can make this thread, not the thread sleep, but like the function sleep right here by writing this logic. What this does, I would urge you to take it as an assignment and understand how exactly this sleeps for 5 seconds, how exactly this logic makes the thread sleep for 5 seconds. I'm not going to go into that here, but this is not too difficult to understand how this one line of code will make sure that yahan first it waits for 5 seconds and only then the request goes out and only then you get back data. Why are we doing this? To see if this backend request took a really long time, let's say 20 seconds, then would we see the buttons? And what would the values be in the buttons during those 5 seconds? Would they be 0? Would they be undefined? Would they be something else? So I've added the artificial delay right here. If I refresh, you will see 1, 2, 3, 4, 5. There was a white screen for 5 seconds. Basically means nothing renders until this function actually resolves. Harkirat, that looks very ugly. It does. Harkirat, how can I add a loader here? That's the default behavior, right? You should probably see a loader here for 5 seconds before the buttons come. We will get to it very soon once we reach this logic of use recoil state loadable. Cool. So what have we learned? We have learned asynchronous data queries specifically for cases like these when you want to initialize an axios.get, initialize based on an axios.get or some asynchronous operation. This is how you would initialize the notifications atom or whatever you want. Basically, if you want to get your users data, for example, whenever you go to app.100xdev.com, you either see sign in here or log out here based on whether or not the person is logged in. You see join Discord and assignments here only if the person has made at least one purchase. So these also resolve based on an atom value, which again is initialized like this by sending something to the backend and getting back some data and checking whether or not this user is actually logged in. So this sort of a very other common important standard atom that you will see would be the user atom, which will be like, will do the same thing, but here you will hit another backend route that will actually tell you whether or not the user is logged in. Cool. That's it for asynchronous data queries. This is the final solution. Basically, the notifications atom changes like this. And then here, I don't have to do the use effect. I don't have to do any backend sending data logic here. Everything happens here. How do we get rid of the initial flash? Or how do I put a loader in there until the request is going out? We will see very soon. All right. That's it for this section. Let's see if I've missed something else here. Asynchronous data queries. I've covered this and that's done. Next up, we're going to understand atom family, selector family, use recoil state loadable and use recoil. This will be value. So use recoil value loadable. All right, let's get into atom family next. Let's begin with a problem as to what exactly does atom family provide you that you don't already get with atoms. The problem is that sometimes you need more than one atom for your use case. Harkirat, that is fine. We just saw that a few slides ago where we had a few atoms. You can create multiple atoms. What's the problem there? I'll share very soon. For example, let's say you're creating a to-do application which has multiple to-dos. Question. Let's say I ask you to create a component that takes a to-do ID as an input and renders that to-do on screen. This is what a to-do looks like. Has an ID, title, description, and completed. Completed basically means that you're finished with this to-do, so you can consider that as done. You get this from a backend. When you give it an ID, you need to store the to-do in an atom. You cannot use state, so that is a prerequisite here. You have to store this in recoil, and all to-dos can be hard-coded as a variable for now. Eventually, we will see how you hit a backend server and get these back as well. For now, assume you have a file. That file has all the to-dos listed down. How would you make sure you store values in atoms, and you create a component that takes an ID as an input and renders that to-do, basically means renders the to-do which has that specific ID. Would you have a single atom in this case? Would you have one atom per to-do? Or would you create and delete to-dos dynamically? How would you create and delete to-dos dynamically? Basically, the problem that will come here is, let's go to the code base and understand the problem a little bit better. So amongst the code bases for this library, for this class, atom family, this is the one that you need to open. And if you look at app.jsx, you will see this is what we have to do. Inside a recoil root, I am rendering the to-do component twice. And what does this to-do component have to do? Ignore whatever is happening here. It needs to get an ID, get the to-do from somewhere which it exists in this to-dos.ts file, should be JS because we're in JavaScript right now. Let me make things slightly easier. It should get the to-do with that specific ID from here and render it on screen. The only problem is this to-do needs to be fetched via an atom. So how would you basically, how would you dynamically create an atom? That's the problem here. You don't have a single atom. You can be like, Kirat, I will do, again, if you want, you can do it in a different file. Let me do it here. Const to-do atom equal to atom. Key to-do atom value or whatever default, somehow get that specific to do, let's say something like this. You can be like, Kirat, I'll do this and I'm good to go. I have the to do atom. I can say const current to do equal to use recoil value with to do's atom, and I'm good to go. I can render this current to do over here. I would say that makes sense, but you've created a single to-do atom, and these are two components that you are rendering, to-do number 1, to-do number 2. Both of these are getting the same atom. You have not dynamically created two different atoms for both the components. There is a single global atom that exists that is getting value in this component as well and this component as well. Can you see how this will become a problem very quickly? You cannot. What you ideally have to do is something like this. You have to, somehow create a new atom anytime a component is created, so that this has its own atom and this has its own atom. This is the problem with using just atoms. Atoms work when you know something is present only once on screen. But if you have a bunch of to-dos, each will need its own atom, so you'll have to dynamically create more and more atoms. You could argue, Kirat, I will create a single atom which stores the complete list of to-dos, an array here. I would say yes, you could do that. There are downsides to doing this. But I'm giving you the restriction of you have to create a dynamic atom for every to-do that you're entering here. Now, how would you do this? How would you, if there are 5 to-dos that are rendered here, each needs to have its own atom. And of course, if 2 of them have the same ID, then they need to hit the same atom. This is another sort of, you could have done this, you will initialize an atom here. But again, if 2 to-dos have the same ID, they need to hit the same atom. They need to get value from the same atom. If 2 to-dos have different values, is when you have to create a fresh atom for them. How would you solve this problem? And this is the exact problem that atom family comes to solve. What is the problem? If I go back to the slides, the problem is, each component needs to create its own atom. Would you have a single atom? You could have a single atom that has all the to-dos. You have a restriction just from my side for now. You cannot do that. There are also downsides to doing that. But let's assume that we throw away the downsides for a while. You have a single atom per component. How would you create them? Basically something like this. Every component needs to have its own atom now, and you have to dynamically create them, delete them. And if a component is rendered twice, then that specific component, if the ID is the same, it needs to hit the same atom. So if I give, as I showed, if all of these have the same ID, 2 over here, they need to reach the same atom in the end. How would you solve this problem? And the answer is using atom family. Okay, you will, rather than subscribing to the atom, you would subscribe to the atom family. This basically means that whenever you know there are multiple atoms, where you have to create one atom per item, you create an atom family. Call it the to-dos atom family. And here you be like, okay, bhai, whoever is calling me, tell me what to-do ID do you need values for? I will give you a new atom for that to-do ID. I repeat, what does atom family give you? It says that bhai, if a component wants a new atom from me, or an atom specific to an input from me, it will give me the input. I will return it back that specific atom. And this is how you can dynamically create more and more atoms for a use case similar to the one that I'm showing right now. Let's look at what that looks like when you're writing the code. Until now, we've done something like this. Let's say the atom exists somewhere. We've done something like this. Const current to do equal to use recoil value, a to do atom. This is an atom. If you replace this with an atom family, which basically means I would probably call it to-dos atom or to-dos atom family, whatever you want to call it. I'm going to leave it as to-do atoms. You need to pass in the input. Okay, bhai, this is a family and I want which atom for them? I want a to-do with this specific ID. So these inputs will uniquely give you an atom, which basically means we'll see how you define the to-do family. But given that it is already defined, how would you get a specific atom from there? You will not do use recoil value atom family. You will be use recoil value atom family ka this specific atom. I want this atom for this atom family. I want atom 1 from this atom family and not the whole thing. I don't want the complete atom family. I just want atom 1 or the atom for this specific to-do ID. And then from there, things are the same. So the only thing that has changed is that rather than getting an atom, you are telling an atom family, okay, bhai, you will have multiple atoms, which will be different based on this input. Give me the one for this specific input. And if the first to-do gets rendered with ID 1, it will ask basically for this one. And then when the second one gets rendered, it will ask for this second atom, so on and so forth. Why this is cool is because now I can define multiple to-dos with ID 2. All of them will try to get the second atom, which basically means this guy right here. It will not be like this will hit the second atom and this will hit the third atom, so on and so forth. All right, cool. Let's look at how can you define a to-do family, an atom family. If you go to atoms dot, again, TS here, feel free to replace it with JS. I created this as a TypeScript project. I don't know why. So feel free to replace this with .js. And now look at it here. It looks slightly different. Number 1, rather than writing equal to atom, I write equal to atom family. So I'm not doing const to do atom equal to atom. I'm not doing this. Not doing this. What am I doing? Rather than atom, I've written atom family. Key is still the same. Every atom family needs a uniquely identifiable key for that family. In this case, it is written, you can name it whatever you want, just make sure it's not conflicting names ever. And lastly, the important thing, the default value is not a value anymore. It is a function. Again, I've used an arrow function, feel free to use a normal function. But the idea is that the default value here is that, bhai, I know this is a family. Tell me which atom do you want? Give me the inputs and I will return you the default value for that atom. For example, if this specific atom is wanted or asked for, this logic will run for that specific ID. And then if an atom with ID 2 is asked for, this logic will run again for that specific atom, so on and so forth. If the same atom is asked multiple times, then only the first time this will run, and then eventually it's just a cached value similar to how an atom is defined. So it's really nothing new. It's just a way for you to create multiple atoms is atom family. Atom family lets you dynamically create multiple atoms, which is exactly what we want in this use case. Okay, bhai, every value of ours, needs to have its own atom. Every to do that's rendered here, 1, 2, 3, how many you render need to have an atom associated with them, and this is how you can create it. Now that I have this is what I'll use here to do atoms family. I've imported it here at the top, use recoil value, and good to go. The important thing here is, another important thing to know is what is the logic that's running here. It's basically going through this hard-coded list that I have and trying to find that specific to do. In my case, this find function, if you don't know, is a very popular, similar to map and filter. It lets you find a specific function, a specific value that follows these constraints. And what is the constraint in this case? Okay, by given this ID, find a to do which has the specific ID. If there exists one, this returns that specific to do. If not, it returns null or undefined. You can test this out very quickly in the browser here. So if I write const arr equal to 1, 2, 3, 4, 5, and I do arr.find x equal to 1, it returns me 1, which is basically the first value in this input. And then if this is a complex object, you can make this complex and keep going. In this specific case, basically, if you don't understand this logic, alag se try to understand the dot find function, which is an API very similar to map and filter. Only this one lets you find a specific element. If this feels hard, you can also do, const found to do equal to null, and then this works as well. You can iterate over this hard-coded to-dos array for now, and then find the specific one with this given ID and return that. Either of them is fine. The other approach is slightly cleaner though. All right. Now that I have this, if I refresh, if I of course run this, now I'm unsure if it will run considering it was all initialized with TypeScript. 7. Family, npm run dev, npm install. You will have to run npm install locally as well, followed by npm run dev. This needs to be a let. Now if I open this, it doesn't render anything here, and it's probably because it's fine. Use recoil value is not defined. So I can go to app.jsx and import use recoil value. If I refresh, I see both the to-dos rendered here. If I render multiple times the second one, I see the second one rendered multiple times. So what have we done? What is the new thing that has happened here? Again, this might feel, why does this look so clean, Harkiyat? Why is the background gray? Why are the font so good? It's because I haven't removed the default CSS. If you remove the default CSS here, you'll see an uglier to-do as well. Given this, what is the new thing that has happened? What is the thing that Atom family did that we weren't already able to do with to-dos or with atoms? The problem with atoms was you can totally be like, okay, I will define atom 1 here and then atom 2 here and then atom 3 here, so on and so forth. But you can't keep track of how many, what the developer would put here, because these to-dos will also come from a backend. So there is no point of you to define these by hand. You need someone else who can create a new atom for you. So you can, if you really want to do this in-house and you're like, Harkiyat, I don't want to use atom family, you can create a function, give atom, that actually returns you a new atom. And then, call give atom of ID here. Then it will work. That's probably was what atom family does under the hood as well. Okay, it returns an atom, which is why you have to call this, because this is a function that actually returns the atom to you, and it's not an atom in itself. So you can actually write this yourself if you want, but they give you this out of the box because this is a very common use case for you to want to store multiple to-dos, multiple notifications, multiple posts on a LinkedIn feed. If I open my LinkedIn feed, you will see 1,000 posts here. It is a common use case for you to, store all of these individually. This is a good post. Follow your passion is probably the worst. Agreed. So you would commonly want to store all of these in different atoms. Again, as I said, you can totally be like Harkirat. I will be like export const to-dos atom equal to simply an atom whose key is atom and then default value is the to-dos array. Here it is an atom which returns an array of values. You can do that. The downside here is, even if one to-do changes, all of these re-render because all of these depend on to-dos atom, which is, a list, versus if you go down the other route, which is, you creating separate atoms for every values, then only if to-do one changes, only this guy re-renders and all of these don't re-render. So that is why you would want to probably have a separate atom for each one of these values, and atom family lets you do this. It is a function that effectively returns you an atom, which is why you have to call this function here, and this actually returns you a to-dos one atom basically, which is what you're using here. You can think of this as a function that returns you another atom. In fact, that might be the official definition as well. Let's see. API reference, utils, atom family, returns a function that returns a writable atom. Atom family returns a function is a function. If you call atom family here, it returns a function. So basically this value will store a function which returns a new atom to you. Returns a function that returns a new atom to you, basically lets you dynamically create atoms. And that is exactly what we need in this use case. Harkirat, does it create the same atom twice here? No. If you give it the ID 2 multiple times, it will only create an atom once for all of these. And then if you update the value in one of them, it will get updated in the other ones as well. We can confirm that by doing this. I can basically be like, यहाँ पे I will get the update to do equal to use set recoil state for the second to do, and then after 5 seconds I'm going to call update to do with some random ID, remains the same, but title changes to new to do, description also changes to new to do. What have I done? I have said that I'm going to get the atom with ID 2 and update it, because I'm using use set recoil state here, and update it with new values. Let's see which one of these actually gets updated. Do all of them get updated? Does only one of them get updated? Do none of them get updated? If I go here and refresh, you will see after 5 seconds, no one gets updated. That's a little fishy. I would have expected all of these to get updated unless I'm missing something. Component must be used inside recoil root. That makes a lot of sense. So let me move this inside another component, updater component. And here this component can return an empty div. And here I'm running the logic to update after 5 seconds. Now let's wait for 5 seconds. And there you go. All of them got updated. What does this tell you? This tells you that if you ever call to-dos atom family with some inputs, if those inputs are the same here and in all of these to-dos, basically the ones that have ID equal to 2, here, this will return you the same atom everywhere. It's similar to recoil under the hood having created a export const atom for to-do 2 for you. It created an atom for you, and anytime someone asks the atom with ID 2, it returns the same atom to you, which is why value updated from one of them updates it in multiple places, which is what you want as well, right? If there are multiple to-do components rendered, if the value changes in one place, you want it changed in other places as well. And that is what atom family lets you do. This guy right here, feel free to try it out on your side. If you want to go through the docs, if you did not understand it well, you should. Can you work without it? Yes. As I said, you can just create an atom which has all the to-dos in it. Should you? Maybe. But is this the most optimal way to solve, for example, a to-dos problem? Yes. This is probably the more optimal way to do it, rather than, storing it all in a very big list, which is an atom. All right. That's it for atom family. It sounds so much like Adam's family every time I say it. And this is the final solution. Okay, you've created a to-do atom family with the default value of which is take an ID as an input and then return this. The important thing to know is the default value always, not always, you can actually probably make this a value as well if you want every atom to have a default value. But usually the default value would depend on the input. So you will put a function here rather than a number or a string or an object, because this function will take that ID as an input and then finally return you the specific output given that input. This is great, but what is this missing? This is missing what if this data is present on a backend? How do I get this data from the backend and actually render it here? Which is what we will discuss next when we get into selector family. All right. Next up, what's left? Selector family. And in these two hooks that I need to discuss, let's kick things off with selector family here. Selector family in the to-do application, this is fairly straightforward. So thankfully, we understand if you want asynchronous calls in an atom, you need a selector. And similarly, in our to-do application, if you were supposed to get to-dos from a backend, is when you need a selector family. So basically, if I tell you, okay, this is an endpoint that you can hit that gives you a to-do given an ID as an input, how can you hit this specific server, get back the data from the server, and then use this data and render it rather than getting it from in memory, basically, which is how things were happening until now. Let's see how you would achieve that. If I go here, you will find another module here called selector family. Try to open it and explore it locally. This selector family pretty much writes the code for this. Okay, how can you actually hit a backend and get data from there and render it rather than getting it in memory? So there's a recoil route, renders two to-dos. And again, this code looks fairly straightforward, simple. We've done this many times. Okay, get it from an atom. But if you look at the atom code now, it's slightly different from the atom code we wrote in the last slide. What was the atom code we wrote in the last slide? If I go to this right here, the default value given the ID would return the found to do to you. Okay, basically given this ID, it would iterate over this to do's array and then finally return you the found to do from this in memory array. What do we have to do now? Actually hit a backend. And what did I say? Okay, bhai, atoms cannot have asynchronous backend calls in their default value. They need to use a selector. But when you're doing the same thing for an atom family, you cannot use a selector. You have to use a selector family. Basically, if you have an atom family where every independent individual atom needs to be fetched from a backend, you cannot do an asynchronous function here. I could not over here in our existing assignment just write, get where did it go? Atoms.js. I could not just write async and hit a backend here. As we've discussed, the default value for an atom or even for an atom family cannot be an asynchronous call or an asynchronous function. So what do? We pretty much say, if I go back to selector family /atoms.ts, I say that bhai, the default value is going to be a selector family, which the default value for which can do an async call. But this is slightly different from selector. How did we create an async atom? We said const to do equal to atom key whatever to do, and then default, I said a selector, not selector family, a selector which had a key, and then a get which was an async function. This is something we did a while back when we were discussing asynchronous data fetches, which was right here. When we discussed asynchronous data queries, I shared that code would look something like this. We would have an atom and the default value will be a selector, which will have an async function to get the final data. You have to do the same thing here, only this will boggle your head the first time or even the second time or how many times you look at it. What is this get here? It says it is a function which returns another function which returns this body. Again, this is slightly complicated syntax. You can actually write this a different way that will make this slightly easier to understand. Let me do that. This is how you should write it in production usually, but a slightly easier syntax is this. There you go. This is slightly easier syntax. Okay, bhai, for this to-dos atom family, whenever an ID is given as an input, return this specific function which can use this ID and then hit the backend and return the data. Feels complicated? It should. It is basically returning, it is equivalent to a function which is returning another function, which is why it's a little complicated. Why does this need to happen? Because atom family returns multiple atoms, does not return one. Each atom will have a specific ID input. Whoever is calling this atom ID, atom family, as we discussed in the last slide, will pass in an input. Okay, bhai, this is my ID. I need the to do for this specific ID. When that ID reaches here, you need to send the asynchronous backend call for this specific ID. So rather than doing this, which is what we were doing until now, okay, if this was a selector, this was the code. Okay, bhai, if this is a selector, then the get function is an async function, send the to backend call and return it. But since this now is a dynamic selector, it needs to return a different value given a different input. This ID field is dynamic. This changes a bit. This is a function which takes the ID as an input, which returns the final function that you send the outward call from. This syntax we have seen in the last atoms.js. If you go here also the default value was a function that takes ID as an input. So here also the get value needs to be a function that takes an ID as an input. Only it needs to return another function which is asynchronous, which sends the to do call. This will take some time for you to grasp, totally should. But if you look at even the selector family docs here, you'll find some variation of this. Let's go through the docs. Returns a function that returns a read-only recall value state or error. A selector family is a popular pattern similar to selector, but allows you to pass get and set callbacks to selector. The selector family usually returns a function which can be used with user-defined parameters. The selector family returns a function which can be used with user-defined inputs. What are user-defined inputs? The ID that I'm passing here. Ki haan bhai, the selector for this specific atom is this, and returns a selector. Each unique parameter value returns the same MI selector instance. Let's see if there is a good example here. There you go. This is the code that very similar to, this is exactly what we're looking at, right? An asynchronous query example. Even though this is just a selector, we need an atom. Let's see if there's an atom family here. I think it might be here. There you go. This is the example that we're looking at right now in our to-do application. We have defined an atom family which has a key, and a default value is a selector family which has a key, and the get has a parameter which returns a function which does your asynchronous function calls. For dynamic default based on other use state thing, which also has a thing, don't just use selector atom family. Basically, this line basically states or is like an important thing to know, okay, why you shouldn't use a selector here. Whenever you're using an atom family, use a selector family here. Why? Because if you don't, then you're just creating a single selector. And as we have learned, atom family creates multiple atoms. It does not create a single atom. And if you don't use selector family here, for every atom, the selector will be the same, which will, for at least it will have the same key here, which is something we don't want. Which is why whenever you're using atom family here, use selector family. Key is this. This is the most difficult bit here to understand. Okay, the get function here isn't simply a function like we've seen many times now. It is a function which has the input parameters, which returns a function that we've used until now in selectors. This is the only sort of difficult bit to digest here. Let's see how this looks. Let's see if it runs, and then we can try to dive deeper into this. npm install, npm run dev. Again, the same error. Oh, sorry, I need to fix this bit right here. There we go. So if I go here, it says to do 1, this is to do 1, to do 2, this is to do 2. It is sending 2 backend requests. If I go to the network tab here, you will see it sends a request to some server / to do $ID equal to 1 and $ID equal to 2. What happens if I put the second to do multiple times? Does it send us a request to the backend for everyone, or does it send it only once? It sends it only once. The value is still cached, similar to how I showed you in the last slide. Okay, all of these will point to the same atom now, and each atom will have its own selector. And why did we need to use a selector here? Because we're doing an asynchronous backend call. In the last assignment, we were not. We were just getting it from memory. So in that case, you don't even need a selector here. You can just write the logic to find that to do. But if you have to hit the backend for every to do, then this needs to be a selector family. And now you have pretty much a decent code base for actually hitting the backend and getting back a to do and rendering it on screen. Given you have the restriction, कि हाँ भाई, each one of these needs to have a separate backend call. Again, as I said, if you want to really create this, you can create this. I have also exposed on the backend / to do's endpoint, which returns all the to do's. So you could just use this, but the whole goal was to understand atom family and selector family. And you will see use cases where you will need to create atoms dynamically. That is what atom family lets you do. And if the default value of it needs to be asynchronous, that is where you need to use selector family. All right. That's a brief of atom family, selector family. Did not understand, felt a little overwhelming. Could, specifically the selector family bit. Practice a bit more is all I can say. Amongst all the things that are present here, the most important ones are atoms and selectors. Some of these hooks, not all of them. And if I'm being honest, atom family and selector family is something you should know of. So even if you did not understand it through this video, I don't think there are a lot of videos on atom family and selector family out there. So you will have to just write a lot of this code. More specifically, just get comfortable with this syntax. This is the line that will most probably confuse you, which is a function which returns a function. If you write it a different syntax, you might be able to understand it better, which was basically the syntax that I wrote below. So try to digest this bit, and that's it. That's all you need to know in Recoil. The only other thing that's left is use Recoil state loadable and use Recoil value loadable, which is what I'm going to discuss next. All right. What is the problem? Do we have another time? We have another loadable, so that's the solution. Okay. Now I'm going to ask you something. So the selector part is done, by the way. Next up, we need to understand 2 more hooks that Recoil gives you. Use Recoil state loadable, use Recoil value loadable. What happens when the values aren't loaded immediately? For example, when the to-dos are coming back from the server, how can we show a loader on screen when that is happening rather than just showing an empty state? I showed you a few slides ago. Okay, if this asynchronous backend call takes a lot of time, the screen remains blank. You don't see anything. For example, if I add an artificial delay here, for 5 seconds, you will notice if I go back to the website, there's nothing I see for 1, 2, 3, 4, 5 seconds, after which I see everything because the backend calls don't even go out. This function sort of remains hung for 5 seconds, after which we're actually sending the backend call. I can totally add this artificial delay on the backend. I can totally, go to a different Wi-Fi that's smaller in speed. All of them would simulate the same thing, which is the backend call is taking a long time. How can I show a loader here when that is happening? There are a few ways. There's also like the suspense API that we talked about a few classes ago that you can use here. But one way is you use, rather than doing a use recoil state, you use recoil state loadable. I repeat, rather than doing this, all you have to do is this. And this guy now returns you a few things. The to-do that you get here, if you hover over it, you can actually see what it returns you. This is all TypeScript. If you don't understand it, it's fine. But it basically returns you these few things. State and contents are the important bits to know. This to-do is no longer your set of to-dos. It is an object which has a few things. Some of those things being contents and state. This state variable represents whether or not this has resolved, whether or not this has returned a value for the first time. If I log state here, let's see what comes. Go back here and refresh. If you go to the log, state is not defined because it is going to be to-do.state. Refresh. And you will see state is logged as loading initially, which basically tells you in the component itself, okay, it is loading. And after 5 seconds, it logs has value. Which basically means I can put a check here. If to-do.state equal to loading, then return loading. And then I can add an else if to-do.state equal to has value, then I can render my actual to-do. This will also change a bit. As I said, state is one thing you get here. The other thing is contents. So you don't have a to-do.title. You have to-do.contents.title and to-do.contents.description. Now if I refresh, you will see, I see loading. And then after 10 seconds or 5 seconds, you see the actual to-do. This is how you should actually build an application where, if you're doing asynchronous calls, you don't want the website to be hung for however long this asynchronous call might take. You want to show some feedback, which is why you might have heard of this thing called skeletons or seen skeletons on websites, which are basically something like this. Okay, when something is loading, you can show such a skeleton on screen so that, rather than loading ... a skeleton shows up. So the user knows, okay, something is loading. How can you add a skeleton? We'll see very soon when we reach the styling bit of movie entailment. But rather than showing loading ... you should show a skeleton, which is something you can pretty easily add. What is a skeleton? It's just a div which has some opacity. So that is, this is one way to do this. Okay, you use recoil state loadable, or if you just want the value and don't worry about set to dos, then you can do use recoil value loadable. And pretty much gives the same thing. Okay, now it has to-do contains two things. It contains your actual value here whenever it gets resolved, and a state which could be loading, could be has value. It could also be has error. To-do.state equal to has error. What if this backend call fails for some reason? What if it does not give you data? What if it gives you a 500 status code? I can actually simulate an error here. Okay, some error is thrown. Backend call failed. The same thing would happen if this asynchronous call failed for some reason. If my backend is down, if I hit an endpoint that doesn't exist, let's say I hit this endpoint. In this case, this should throw an error, or this will throw an error, in fact. And you can catch that here as well. Okay, by the backend call failed, and then you can show to the user error while getting data from backend. Now if I refresh after 5 seconds, it says error while getting data from backend. Basically means neither is the data loading anymore, neither did I get a value. The backend threw an error. If I refresh, if I open the console as well, you will see both the backend requests fail because that endpoint doesn't exist. I've put in a erroneous endpoint there. Both of these calls failed with a state. What does failed mean? It means the status code isn't in the 200 series. It's a 400 or a 500 status code. And so Axios sort of throws an error here. As I said, you can also throw an error like this. But again, Axios the library also throws an error. If you use fetch, that will also throw an error when this specific endpoint fails. And right now, since this endpoint doesn't exist, we get a 404 from the server. And that puts in this hook, okay, bhai, the thing failed. So you can handle this more gracefully. What would happen if I'm not using loadable here? If I'm just using use recoil value, what would happen if I refresh? After 5 seconds, bunch of errors here. Error, basically your app will literally crash. If you have, let me put some hi there above this. Hi there, refresh. Where is the hi there? As it is loading. And then eventually even the hi there does not appear because your application actually crashed, which basically, blows up your DOM. So you should handle these errors more gracefully. And how do you do that? This is one way of doing it, which is, use recoil value loadable and use recoil state loadable. Another way is the suspense and the error boundary API, which happy to discuss at some point, even though I would urge you to understand these yourself, or like at least Google these yourself. Basically, if I have a use recoil value of something that takes some time, I can wrap all of that inside a suspense with a fallback equal to loading. And now if I refresh, use recoil value is not defined. If I refresh, you see a single loading, slightly cleaner than, loading that we saw. And then eventually it crashes. So you see nothing, but you can also add something called an error boundary here, which does not exist in functional components. So you have to get into class-based components. So a bit happy to take a special video on both suspense and error boundary, but that's another way for you to fall back to something while your hook is loading. But what is the other way? It is use recoil value loadable. You can use if you use recoil value loadable, then you don't need suspense. Even suspense won't trigger when you do a use recoil value loadable. But if you do a use recoil value, then suspense will trigger and you will see this loading ... on the screen. Happy to discuss this in a different video. That is all I had for today. Slides I will post very soon and hopefully was insightful. You understood at least Atom and asynchronous queries and selectors. If you understood Atom family, great. If you understood selector family, also beautiful. I think that was one part which can still be a little confusing, which we can practice a bit more and understand. You don't need a lot. I mean, you don't see a lot of selector families in your application, thankfully. And if you really want, you can go a little unoptimal and use atoms everywhere and not use selector family. But with practice, if this wasn't clear, hopefully that becomes clear with time. That's it for this one. I'll see you guys in the next one. Bye-bye. Our battery is almost dead.